We've been monitoring the emperor penguin population and we found it's going down faster than we predicted. They're declining over a 15-year period by about 22%. So that's significantly faster than previous research, but also even faster than the worst case scenario models, which are predicting that emperor penguin populations might not even be here by the end of the century. The previous population estimates, which went up to 2018, suggested that emperor penguin populations declined about 10%, 9.5% over a 10-year period. Our estimate is over a longer period and brings it more towards the current day, and it shows a much greater decline. The future of emperor penguins isn't looking good. We know that the population estimates from models show that there'll be virtually none left by the end of this century. But our data that we're getting at the moment, which is only from a section of the Antarctic, so it's not everywhere, those actual data show that populations are changing and decreasing faster than even those models predict. There are a number of factors which influence emperor penguin populations, but all of them are linked to climate change and global warming. Emperor penguins use sea ice for almost all of their life cycle. They breed on it, they forage and hunt under it, and they molt on it in the summer. If the sea ice gets smaller and breaks up early, then the chicks will go into the water before they're fully fledged, and that basically means they get drenched and they die of hypothermia. But also, we are seeing increased rainfall events in Antarctica. We're seeing more competition from other animals which go in further south and interact with emperor penguins, and possibly more predation from animals that can get to the emperor penguin colonies that previously couldn't. We use satellite imagery to track the emperor penguin populations. Most of the colonies are in extremely remote places. Very, very few of them are monitored on an annual basis. Many of them have never ever been visited by humans. So satellites is really the only way of doing it. And we use a machine learning approach where we estimate the area of emperor penguins in the very high resolution satellite imagery. And then we add that up using densities that we know from ground truthing and calculate the number of penguins at each site each year over that 15-year period. So the emperor penguin colonies are quite mobile. If you live on the sea ice, it's a very dynamic environment, so they often change their position depending upon where's the best bit of sea ice. So each year we have to go and find them before we send the high-resolution satellites to go and take an image of them. To do that finding, we use the guano signal, the brown staining on the ice, using coarser resolution imagery. So we're quite literally looking for the poo. So we're using a sector of Antarctica from about 0 degrees to about 90 degrees, which incorporates the Weddell Sea, the Peninsula and the Bellingshausen Sea. This sector includes areas like the Peninsula, which have warmed really fast over the last few years, but also areas like the Weddell Sea, which have stayed very similar and haven't seen any sea ice loss. So it encompasses a wide range of environmental factors and conditions. So this research is using just that section of Antarctica. What we really need to do now is have a look around the rest of Antarctica and see if that's doing the same as this particular area. We have very worrying results here, but we're not entirely sure that it is the same over the whole continent. So that's the next step. With emperor penguins, there are very few things that drive their populations except climate change. It's just the environmental factors. You can't put the ice back or cool the air down. It's really about global warming and reducing people's carbon and methane emissions. That's the only thing which will really save the emperor penguin.